Welcome to properties of the function y equals ax squared plus bx plus c. And this is the other form of our quadratic function. First one, of course, being vertex graphing. This one is our standard. And that's where a, b, and c have to be real numbers, which they will be, and a can't be 0 because, of course, if a is 0, it will get rid of this first term here, and then, of course, it won't be a quadratic function. So what we're going to learn, very similarly to when we learned about a, p, and q, we're going to learn about a, b, and c. And the nice thing about this one is that a is the same. So if a is greater than 0, the parabola will open upward. And if a is less than 0, the parabola will open downward. B helps us determine the axis of symmetry. And A and B help us determine the vertex, and C is the y-intercept. So we're going to do a couple of different sets of notation here, which you learned in Foundations and Pre-Calculus 10. We can have a function be f of x, or we can also have it be in that form right there. So in order to calculate the x-coordinate of the vertex, it's calculated using x equals negative b over 2 times a, which you can see in the notes. So first of all, we'll start with this first one. Let's just look at the information. We can tell by the numerical coefficient that it will open up. Vertex we have to figure out, so I don't need the formula, but I highly recommend at least starting out with it just to make sure you put the numbers in the right spot. So b, of course, is 6, so we're going to have negative 6 over 2, and then a is 1 equals negative 6 over 2 equals negative 3. And then we're going to take our negative 3 and we're going to substitute it back into the equation. Remember, when we're substituting in negatives with the squared, it is an understood set of brackets because that will affect our value. So what do we have here? 9 minus 18 plus 5 gives us negative 4. So as you can see, figuring out the vertex from standard form is definitely more complicated than vertex graphing form. Negative 3 comma negative 4. So now that we have our p and q, we can deal with the rest of these. So our axis of symmetry will be x equals negative 3. And we'll move over here to domain range, max and min. Just trying to see if I can get it to fit all on here. Domain we know is x is an element of real numbers. Range, right? So if it opens upward, we know that our range is going to be our q value. So y is greater than or equal to negative 4. Y is an element of reals. Because it opens upward, it will have a minimum value of negative 4. This one's going to be a little bit more complicated just because its vertex is not, will not be integers, they'll be rational numbers. So we can tell that because a is positive, it opens up. And I think what I'm going to do is I'm just going to slide this over here and do my work for the vertex over here. So x equals negative b over 2a. Which is negative 3 over 2. So that's our x coordinate of the vertex. So now we're going to have to go 3 over 2 squared. I'm plugging in that x value back into the equation to determine our y value. 9 over 4 minus 9 over 2 minus 10. So we're going to need a common denominator here. 18 over 4 minus 40 over 4. So we've got 9 minus 18 minus 49. Sorry, minus 40 equals a negative 49 over 4. So not exactly the nicest vertex. But we're not limited to any sort of particular type of number. So our vertex is 3 over 2 and negative 49 over 4. Axis of symmetry, of course, is x equals 3 over 2. And I don't, as long as we've got terminating decimals, I think we're good with dealing with decimals, unless it specifies keeping it in fraction form. But domain x is an element of real numbers. Range opens upward again, so y greater than or equal to negative 49 over 4 or negative 12.25. Y is an element of reals. Another minimum value of negative 49 over 4. And that's the end.